This video is going to take you through the 6-3 warm-up and then the notes for 6-4. So if you haven't already allowed everybody time to work on the warm-up, if you'll pause it for about 5 minutes, give everybody a chance to work on the warm-up, and then resume when you are finished so that I can go over the answers to those questions. All right, we talked about vectors in 6-3. We said the component form is x2 minus x1, comma, y2 minus y1. So in this example, this is my x1, this is my y1, this is my x2, my y2. I would do negative 8 minus 1, comma, negative 9 minus 3, and I'd get negative 9, negative 12 for A, the component form. Then B is the magnitude. So you can either, this is component form, for magnitude, you can either do the distance formula, x2 minus x1 squared plus y2 minus y1 squared. Or if you already have the component form like we do, then you can do the square root of a squared plus b squared. So a would be negative 9. This would be the square root of negative 9 squared plus b, negative 12. Square root of 81 plus 144, 225, and the square root of 225 is 15. So component form, which is A, and magnitude here, which is B. Number 2, 3, and 4, I'll use that U is negative 5, 3, and V is 0, 0. So for U plus V, I'm going to take and add negative 5 plus 0, and then 3 plus 0, and I get negative 5, 3. For U minus V, I'm going to do U minus V, comma, the U minus V, and I get also negative 5, 3. For 4, I'm going to do 2U times 3V, so 2 times U minus 3 times V. So I get negative 10, 6, minus 0, 0, which is negative 10, 6. And number 5 is in IJ form. It says if U is negative 3I plus 4J and V is 2I minus J, find 2U plus V. So remember, we can take this and we can put it into component form if you're more comfortable that way. And then distribute the 2 in. And then add these. And I'd get negative 4, 7. Or you can treat them just like their expressions. So I can say 2 times negative 3I plus 4J plus 2I minus J. So I distribute negative 6I plus 8J plus 2I minus J. Negative 6 plus 2 is negative 4I, positive 8, negative 1, positive 7J. So because it was given to us in this IJ format, we would want to make sure our answer's in this format, which means I need to come back up here if I did it this way and make sure I put it back into IJ format. The first one gets the I and the last one gets the J. Okay, 6-4 is called vectors and dot products. We're going to go a couple more concepts into vectors and including the dot product. The dot product is how we sort of multiply vectors. So we don't just multiply vector by doing the first times the first and then leave it in the first and the second times the second. What we do is called the dot product, and the dot product is first times first plus second times second. So if I had 2, 3, and 4, 5, then I would do 2 times 4, which is 8, plus 3 times 5, which is 15. Combine those together to get one single number. So the answer to dot products should be one number. Example 1 says, find the dot product of U and V. So I take and multiply 6 times negative 2, and I add it to 1 times 3. Negative 12 plus 3, which is negative 9. For B, it's in IJ format, so this might be easier to write it in component form. First times first, 3 times negative 2, plus second times second, 4 times negative 3. And I get negative 6 plus a negative 12, or negative 18. You can also do first times first, plus second times second, leaving it in IJ format, and you get the same answer. All right, so these are all the properties of the dot product. We can switch the order around and it won't change it, just like with multiplication. So I can do u times v or v times u, and it will still give you the same answer. If you've got the dot product in conjunction with a sum or a difference, you can distribute it just like you do multiplication with addition or subtraction, as it's inside the parentheses. Any vector times itself is the same thing as the magnitude. Remember, these blocks mean, or these lines means the magnitude of that vector squared. So if I did v dot v, it's the same thing as finding the magnitude of v and then squaring it. And this last one says if there's all multiplication, so there's no addition, that's why it's different from this one, then I can multiply these in any order. I can do c times u first, then that times v. I can do c times v first and that times u, or true to the parentheses, u dot v first and then that times c. C being a scalar. So scalar just means a single number. All right, so example 2 says use u is negative 5, 6, v is negative 3, 4, w is 1, negative 2 to find the indicated quantity, and then state whether the result is a vector or a scalar. So if it's a vector, it will be in component form, and if it's a scalar, it will be a single number. A says u dot u. So remember, there's two ways to do this. One is take u and find its dot product with itself. So first times first, negative 5 times negative 5 plus second times second, 6 times 6. And I'd get 25 plus 36, or 61. Or I can do the square of its magnitude. So I could do the square root of a squared plus b squared. And then square it, and I get that 61. So either way, you get the same answer, which is 61. And because it's just a single number, this is a scalar. B is 3 times v times, 3w times v times u. This is all multiplication. There's no addition here. So I can multiply this in any way I want. Typically, I would say our gut instinct says multiply 3 times w. So 3 times w would be 3, negative 6. That times v times u usually means take this and multiply it times v next. So 3, negative 6, v, negative 3, 4. And then at the end, I'm not going to forget I got to multiply by u. So this is dot product 3 times negative 3, which is negative 9, plus negative 6 times 4, negative 24, and I get negative 33. And that u is still there. So negative 33 times negative 5, 6. And I get 33 times 5. Negative and a negative, so this is positive 165. And then 33 times 6. One's negative, one's positive this time, so it's negative 198. And this time it's in component form, so this is a vector. All right, and using the dot product to find the magnitude. So we know one way to find magnitude. Well, we know two. Distance formula is the first if we've got the initial and the terminal. Then we know that it's the square root of a squared plus b squared if it's just component form. Now we're saying because u times u is the same thing as the magnitude square, we can find the magnitude by square rooting both sides of these. So it's the same thing as saying the square root of any vector and itself. So example 3 says use the dot product to find the magnitude of u. So we just said that the magnitude of u would be equal to the square root of any vector and itself. So I would say that this is equal to u times u, or the square root of u times u. So first and first, 3 times 3 plus second times second. 9 plus 16, square root of 25, which is 5. You can also get it by just doing the square root of a squared plus b squared. This is just another way to do it. And we're going to do it this way because that's what these instructions are saying. Okay, b is u, and that's just 3I, which means there's no j. This would be 3, 0. So it would be the magnitude of 3, 0, and 3, 0. 3 times 3, which is 9, plus 0 times 0, which is 0, square root of 9, which is 3. The angle between two vectors. So these questions are going to require a calculator. So on your test, this would be on the part that requires a calculator. And this is the equation or the formula for finding the angle between two vectors. If I've got a vector here and a vector here, and I want to find the angle between them, I can say that the cosine of that angle is equal to the dot product of the two vectors over, and this should be magnitude, the magnitude of each, or the product of the magnitude of each. So the last thing we're going to do, because this is cosine of theta, we're going to say cosine negative 1 of whatever we get from u dot v over the magnitude of u times the magnitude of v. So example 4 says find the angle between the given vectors. So again, cosine of theta is equal to u dot v over magnitude of u times magnitude of v. So the cosine of theta for A is equal to, dot product here would be 1 times 3 plus 0 times negative 2, which is just 3. And then in the denominator, the magnitude of u would be the square root of 1 squared plus 0 squared, square root of 1, which is 1, times the magnitude of v, which is the square root of 3 squared plus negative 2 squared, square root of 9 plus 4, which is the square root of 13. So the cosine of theta equals 3 over the square root of 13, and I do cosine negative 1, 3 divided by root 13. There's no need to rationalize that because we're going to let our calculator do the work here. And I get theta equals 33.69 degrees. Now, an easy way to check to see if you're on the right track is actually plot these. So if we want to eyeball what 1, 0 would be, we're going to go to the right one, not up or down at all. So that's that vector. And then 3 1, 2, 3, negative 2 would be somewhere down here. And so we're looking at this angle here, which definitely appears to be acute, a little bit less than 45. If we were 100% accurate, we should be exact. But at least you want to approximate that you're on the right track, which looks like 33.69 is about there. Now look at B. Again, these are in IJ format, so if it's easier to convert them, then we want to start with that. This would be 2, 5, and this would be 3, negative 1. So cosine of theta would equal 2 times 3 plus 5 times negative 1 over the magnitude of of u, which is square root of 2 squared plus 5 squared, times the magnitude of v, 3 squared plus negative 1 squared. So in the numerator, I get 6 plus negative 5, which is 1 over, this is the square root of 4 plus 25, or square root 29. This is 9 plus 1, or the square root of 10. And the cosine of theta equals that. So again, in the calculator, I'm going to do cosine negative 1 divided by, and I'm just going to keep that in the denominator, square root of 29. It will leave your square root open on a graphing calculator. 29 times 10. And I get theta is 86.63 degrees. And I'm going to confirm it by plotting these vectors. So 2, 5 would be right 2, up 1, 2, 3, 4, 5, about there. 3, negative 1 would be about there. And this looks pretty close to 90 degrees, which 86.63 is. Okay, finding the dot product given an angle. So if we take that cosine of theta equals u dot v over magnitude of u times magnitude of v, and we transpose it for the dot product, we would get cosine of theta times the magnitude of u times the magnitude of v. So this is just another way to find the dot product. Let's say we don't actually know the component form of these magnitudes, of these vectors, we only know the magnitudes, then we can still find, as long as we have the magnitude and theta, we can still find the dot product by using this. So this says find u dot v, where theta is the angle between u and v. So again, we just said u dot v is equal to magnitude of u times the magnitude of v times the cosine of theta. So u dot v would equal magnitude of u, which is 5, magnitude of v, which is 4, times the cosine of 5 pi over 6. Just when you thought the unit circle was going away, it's brought back. So this would be on the part of the test that did not have a calculator. You would need to know that if it's over 6, it's root 3 over 2 and 1/2. And if it's 5 pi over 6, it means second quadrant where the x is negative and the y is positive, which means the cosine here is negative root 3 over 2. So this would be 5 times 4 times negative root 3 over 2. This becomes 20 times negative root 3 over 2, or negative 10 root 3. Okay, we're going to finish with orthogonal vectors. Two vectors that are perpendicular are vectors that meet at a right angle, and they're called orthogonal. Or orthogonal, you could call it whatever you want. Two vectors are orthogonal if and only if the result of their dot product is 0. So there's two ways to test for this. The first is to know that they're perpendicular. And if you remember, if you want to compare slopes of perpendicular, They have to be opposite reciprocals. So if you graph two lines and you find, or two vectors, and you find that they're perpendicular, then you would know it's orthogonal. And if the dot product is 0. So if I did u dot v and what I got from there was 0, then I would also know that this is orthogonal. Parallel vectors are parallel if and only if the change in x over the change in y is the same, which can also be viewed as the slopes. So it's just like finding lines that have the same slopes. So I can either say the change in x over the change in y is equal in both, or the change in y over the change in x is equal in both. So parallel, same, orthogonal, opposite reciprocal. Example 5 says determine if u and v are parallel, orthogonal, or neither. So if I rewrite this out of ij format, because u is 2i minus 2j, this would be 2, negative 2. And v would be negative 1, negative 1. So if I did their slopes, and again, you can do change in x over change in y, or change of y over change in x. We could say negative 2 over 2, and then we could do negative 1 over negative 1. This is negative 1, and this is positive 1. So they're not parallel because it's not the same. They are opposite reciprocals, which means perpendicular or orthogonal. And we can also test it with its dot product. So 2 times negative 1 is negative 2, plus negative 2 times negative 1 is positive 2. And the answer there is 0. So if the dot product is 0, or the slopes are opposite reciprocals, then it is orthogonal. If they were the same, it'd be parallel, and obviously if it's neither, it's neither. Okay, that wraps up the notes for 6.4. Please submit the warm-up and the notes in one file to Canvas before the end of the class period or now, so you don't forget, and then use the remaining time to work on the 6.4 homework.